This question is about olive oil. A sample of olive oil is mainly the unsaturated fat Y mixed with a small amount of inert impurity. Structure of Y is shown, and we can see that they've given us the formula and the MR. The amount of Y is found by measuring how much bromine water is decolorized by Y. If we look at the equation, or the structure, we can see that when we write the equation, there are 5 double bonds. So for one Y, we'd need 5 bromines, because remember that when we do the reaction with bromine and alkene, each double bond picks up one Br2 molecule. And so we would, if there's 5 double bonds, we'd need 5 Br2s. It says that we weigh our sample of Y and put it in a 250 flask, and then we put 25 in a conical flask, and we titrate it with our bromine out of our burette. So the suitable target titer is 30 centimetres cubed. Justify why a smaller titer would not be appropriate. It's all to do with errors, because when you calculate a percentage uncertainty, you do the uncertainty of the burette, which is fixed, divided by the reading. Now, the bigger the reading, the smaller the percentage uncertainty. So why would we not use a smaller value? We need to say that smaller titers will lead to larger percentage uncertainties. Then it says calculate the amount in moles of bromine in our target titer. So moles of bromine, it's a volume times the concentration. Moles are very clever. Now, given that our concentration is 0.025 moles per decimetre cubed, our 30 centimetres cubed must be converted from centimetres cubed into decimetres cubed. And if we type this on our calculator, we'll get 7.5 times 10 to the minus 4 moles. So we can write that on our answer line. It says calculate a suitable mass. So mass is Mr. Moles. And we know the MR of the oil is 880 because it told us in the question. What we need to do is find the moles of Y. In order to find the mass of Y, but then it also says it only is 85% Y by mass. So once we've found the mass of Y, that's only 85%. We're going to need to find what the whole oil weighs by scaling up to 100%. So the first thing we need to remember is that when we said our Y would react with 5 bromines, because there was 5 double bonds, so our ratio is 1 to 5. So we're going to take our number of moles of bromine from the previous part, and we're going to divide it by 5 because we're going from 5 to 1. So we're going to take 7.5 times 10 to the minus 4, and we're going to divide that by 5 on our calculator. So that would be the number of moles of Y but that's in our 25 centimetres cubed. Remember that we made a volumetric flask and then we transferred 25 and we did the titration only on 25. The flask held 250, so we need to scale up into the bigger flask, into the volumetric. Now there are 10 25s in 250, so we can either just know that or we can use the scale factor. 250 divided by 25 is 10. We get 1.5 times 10 to the minus 3. So then we can say the mass of Y, mass is Mr. Moles, MR times moles, 880 times 1.5 times 10 to the minus 3. Again, we put that in our calculator and get 1.32 grams. But remember what it said at the beginning, that the oil was 85% Y. So what's 100% worth? What's the mass of the oil? So if we take our 1.32 grams and divide by 85, we'll find out what 1% is worth. Times by 100 and we'll find out what 100% is worth, and we get 1.55 grams. The olive oil solution can be prepared using this method. Place a weighing bottle on the balance and record the mass in grams to 2 decimal place. Add olive oil to the weighing bottle until a suitable mass has been added. Record the mass of the weighing bottle in olive oil. Pour the olive oil into the 250 flask. Add organic solvent to the volumetric flask until it's to the mark. Place a stopper in the flask and invert the flask several times. Suggest an extra step to ensure that the mass of olive oil is recorded accurately. Well, the extra step is needed here. Oops. In this part here. So we need to do something extra right here. So we've weighed this weighing bottle with the olive oil. We've poured the oil into the volumetric flask. The oil is going to be sticking to the sides of this weighing bottle. The exam board is looking for you to remember that when we're making standard solutions, we need to weigh by difference. So we want to re-weigh the weighing bottle after transferring the oil to the volumetric flask. Why would we do that? We want to find the exact mass of oil in the flask. Or you could write down that we would not all the oil would come out of the weighing bottle, some may remain in the weighing bottle. That's the same reasoning. State the reason for inverting the flask several times. We're trying to ensure that that the solution is evenly, thoroughly mixed, i.e. it is homogeneous, all the same concentration throughout. And the question continues. A sample of the olive oil was dissolved in methanol and placed in a mass spectrometer. It was ionized using electron spray, that is where our oil, we just call it M, picks up a proton, becomes MH+. The spectrum showed a peak at 345 from an impurity in the olive oil. The ion with M/Z345 was formed from a compound with empirical formula C5H10O. Deduce the molecular formula of this compound. So if the M/Z of MH plus equals 345, then the MR of our oil, M, is 345 minus the H, so it's 344. We need to add up the empirical formula mass of C5H10O, so empirical formula mass, so 5 C's, so 5 12s, 10 1s and a 16. That adds up to 86. So then we want to take 344 and divide it by 86. And we find out that we have to multiply everything in the formula by 4. So instead of being C5 becomes 5 times 4 is 20. Instead of being H10, 10 times 4 is 40. Instead of being O1, 1 times 4 is 4. So we're going C20, H40, O4.